Tutorial 12, Aviation Weather Services. This lesson will cover aviation weather services. Through a complex system of weather services, government agencies, and independent weather observers, pilots and other aviation professionals receive the benefit of this vast knowledge base in the form of up-to-date weather reports and forecasts. These reports and forecasts enable pilots to make informed decisions regarding weather and flight safety before and during a flight. There are 4 types of weather observations: surface, upper air, radar, and satellite. Surface aviation weather observations, METARs, are a compilation of elements of the current weather at individual ground stations across the United States that provide continuous, up-to-date weather information. Automated weather sources, such as the Automated Weather Observing Systems, AWOS, Automated Surface Observing Systems, ASOS, Air Route Traffic Control Center, ARTCC facilities, as well as other automated facilities, also play a major role in the gathering of surface observations. Surface observations provide local weather conditions and other relevant information for a radius of 5 miles of a specific airport. This information includes the type of report, station identifier, date and time, modifier as required, wind, visibility, runway visual range, RVR, weather phenomena, sky condition, temperature dew point, altimeter reading, and applicable remarks. Although the reports cover only a small radius, the pilot can generate a good picture of the weather over a wide area when many reporting stations are looked at together. The ARTCC facilities are responsible for maintaining separation between flights conducted under Instrument Flight Rules, IFR, in the en route structure. Center radars, Air Route Surveillance Radar, ARSR, acquire and track transponder returns using the same basic technology as terminal radars. Controllers can select the level of weather to be displayed. Observations of upper air weather are more challenging than surface observations. There are only 2 methods by which upper air weather phenomena can be observed: radiosonde observations and pilot weather reports, PIREPs. A radiosonde is a small, cubic instrumentation package which is suspended below a 6-foot hydrogen or helium-filled balloon. As it ascends, the instrumentation gathers various pieces of data such as air temperature and pressure, as well as wind speed and direction. Pilots also provide vital information regarding upper air weather observations and remain the only real-time source of information regarding turbulence, icing, and cloud heights. This information is gathered and filed by pilots in flight. Together, PIREPs and radiosonde observations provide information on upper air conditions important for flight planning. Many domestic and international airlines have equipped their aircraft with instrumentation that automatically transmits in-flight weather observations through the data link system to the airline dispatcher, who disseminates the data to appropriate weather forecasting authorities. Weather observers use 4 types of radar to provide information about precipitation, wind, and weather systems. The WSR-88D NEXRAD radar, commonly called Doppler radar, shown top left, provides in-depth observations that inform surrounding communities of impending weather. Doppler radar has 2 operational modes: clear air and precipitation. In clear air mode, the radar is in its most sensitive operational mode because a slow antenna rotation allows the radar to sample the atmosphere longer. Precipitation targets provide stronger return signals. Therefore, the radar is operated in the precipitation mode when precipitation is present, which can be seen on the top right. Intensities are correlated to intensity terminology for air traffic control purposes, shown on the bottom. FAA Terminal Doppler Weather Radar, installed at some major airports around the country, also aids in providing severe weather alerts and warnings to ATC. Terminal radar ensures pilots are aware of wind shear, gust fronts, and heavy precipitation. The 3rd type of radar commonly used in the detection of precipitation is the FAA Airport Surveillance Radar. This radar is used primarily to detect aircraft, but it also detects the location and intensity of precipitation, which is used to route aircraft traffic around severe weather in an airport environment. And the last type of radar is airborne radar. It is equipment carried by aircraft to locate weather disturbances. Advancement in satellite technologies has recently allowed for commercial use to include weather uplinks. Pilots now have the capability of receiving continuously updated weather across the entire country at any altitude. No longer are pilots restricted by radio range or geographic isolations, such as mountains or valleys. Shown on the left, SIGMETs are weather advisories issued concerning weather significant to the safety of all aircraft. SIGMET advisories can cover an area of at least 3,000 square miles and provide data regarding severe and extreme turbulence, severe icing, and widespread dust or sandstorms that reduce visibility to less than 3 miles. Shown on the right, AIRMETs are weather advisories issued only to amend the area forecast concerning weather phenomena which are of operational interest to all aircraft. AIRMETs concern weather of less severity than that covered by SIGMETs, or convective SIGMETs. AIRMETs cover moderate icing, moderate turbulence, sustained winds of 30 knots or more at the surface, widespread areas of ceilings less than 1,000 feet and/or visibility less than 3 miles, and extensive mountain obscurement. Service outlets are government or private facilities that provide aviation weather services. Major service outlets are the Automated Flight Service Station, or AFSS, the Transcribed Information Briefing Service, or TIBS, the Direct User Access Terminal Service, or DUATS, the En route Flight Advisory Service, or FlightWatch, the Hazardous In-Flight Weather Advisory, or HIWAS, and lastly, the Transcribed Weather Broadcast, or TWEB. The AFSS is the primary source for pre-flight weather information. A pre-flight weather briefing from an AFSS can be obtained 24 hours a day by calling 1-800-WX-BRIEF from almost anywhere in the United States. The Transcribed Information Briefing Service is a service prepared and disseminated by selected AFSS. It provides continuous telephone recordings of meteorological and aeronautical information. Specifically, TIBS provides area and route briefings, airspace procedures, and special announcements. The Direct User Access Terminal Service, DUATS, which is funded by the FAA, allows any pilot with a current medical certificate to access weather information and file a flight plan via computer. The En route Flight Advisory Service is specifically designed to provide timely en route weather information upon pilot request. Hazardous In-Flight Weather Advisory is a national program for broadcasting hazardous weather information continuously over selected navigation aids. The broadcasts include advisories such as AIRMETs, SIGMETs, convective SIGMETs, and urgent PIREPs. These broadcasts are only a summary of the information, and pilots should contact an FSS or EFUS for detailed information. Shown above, navigational aids that have HIWAS capability are depicted on sectional charts with an H in the upper right corner of the identification box. Transcribed weather broadcasts are only available in Alaska and are recorded on tapes and broadcast continuously over selected low or medium frequency and very high frequency omnidirectional radio range navigation system facilities. Generally, the broadcast contains a summary of adverse conditions, surface weather observations, PIREPs, and a density altitude statement if applicable. At the discretion of the broadcast facility, recordings may also include a synopsis, winds aloft forecast, en route and terminal forecast data, and radar reports. Prior to every flight, pilots should gather all information vital to the nature of the flight. This includes an appropriate weather briefing obtained from a specialist at an FSS, AFSS, or NWS. For weather specialists to provide an appropriate weather briefing, they need to know which of the 3 types of briefings is needed: standard, abbreviated, or outlook. Other helpful information is whether the flight is Visual Flight Rules, VFR, or IFR, aircraft identification and type, departure point, estimated time of departure, ETD, flight altitude, route of flight, destination, and estimated time en route, ETE. A standard briefing is the most complete report and provides the overall weather picture. This type of briefing should be obtained prior to the departure of any flight and should be used during flight planning. A standard briefing provides the following information in sequential order if it is applicable to the route of flight. 1. Adverse conditions. This includes significant weather such as thunderstorms or aircraft icing, or other important items such as airport closings. 2. VFR flight not recommended. If the weather for the route of flight is below VFR minimums, or if it is doubtful the flight could be made under VFR conditions due to the forecast weather, the briefer may state that VFR is not recommended. It is the pilot's decision whether or not to continue the flight under VFR, but this advisory should be weighed carefully. 3. Synopsis, an overview of the larger weather picture. Fronts and major weather systems that affect the general area are provided. 4. Current conditions. This portion of the briefing contains the current ceilings, visibility, winds, and temperatures. 5. En route forecast. A summary of the weather forecast for the proposed route of flight. 6. Destination forecast. A summary of the expected weather for the destination airport at the estimated time of arrival. 7. Winds and temperatures aloft. A report of the winds at specific altitudes for the route of flight. The temperature information is provided only on request. 8. Notices to airmen. Information pertinent to the route of flight which has not been published in the NOTAM publication. 9. ATC delays. An advisory of any known ATC delays that may affect the flight. 10. Other information. At the end of the standard briefing, the FSS specialist provides the radio frequencies needed to open a flight plan and to contact EFS. An abbreviated briefing is a shortened version of the standard briefing. It should be requested when a departure has been delayed or when weather information is needed to update the previous briefing. An Outlook briefing should be requested when a planned departure is 6 hours or more away. It provides initial forecast information that is limited in scope due to the time frame of the planned flight. This type of briefing is a good source of flight planning information that can influence decisions regarding route of flight, altitude, and ultimately the go/no-go decision. Aviation weather reports are designed to give accurate depictions of current weather conditions. Each report provides current information that is updated at different times. Some typical reports are METAR, PIREPs, and radar weather reports, SDs. Shown above is a METAR. A METAR is an observation of current surface weather reported in a standard international format. METARs are issued hourly unless significant weather changes have occurred. A special METAR, SPECI, can be issued at any interval between routine METAR reports. A typical METAR report contains the following information in sequential order. 1. Type of report, METAR. There are 2 different types of METAR reports. The first is the routine METAR report that is transmitted every hour. The second is the Aviation selected SPECI. This is a special report that can be given at any time to update the METAR for rapidly changing weather conditions, aircraft mishaps, or other critical information. 2. Station Identifier, KGGG, a 4-letter code as established by the International Civil Aviation Organization, ICAO. Above shows the identifier for Gregg County Airport in Longview, Texas, K being the country designation and GGG being the airport identifier. Alaska identifiers always begin with the letters PA, and Hawaii identifiers always begin with the letters PH. 3. Date and time of report, 161753Z, depicted in a 6-digit group. The first 2 numbers stand for the day of the month. The last 4 stand for time converted to Zulu time, which is depicted at the end with a letter Z. 4. Modifier, auto, denotes that the METAR came from an automated source or that the report was corrected. If the notation auto is listed in the METAR, the report came from an automated source. It also lists A01 or A02 in the remarks section to indicate the type of precipitation sensors employed at the automated station. When the modifier COR is used, it identifies a corrected report sent out to replace an earlier report that contained an error. 5. Wind, 14021G26. Reported with a 5-digit code unless the speed of the wind is over 99 knots. The first 3 digits indicate the direction the true wind is blowing in tens of degrees. If the wind is variable, it is reported as VRB. The last 2 digits indicate the speed of the wind in knots. If the winds are gusting, the letter G follows the wind speed, followed by the peak gust recorded. 6. Visibility, 3/4 SM. The prevailing visibility is reported in statute miles as denoted by the letters SM. It is reported in both miles and fractions of miles. At times, runway visual range, RVR, is reported following the prevailing visibility. RVR is the distance a pilot can see down the runway in a moving aircraft. When RVR is reported, it is shown with an R, then the runway number, followed by a slant, then the visual range in feet. 7. Weather, plus TSRA-BR, can be broken down into 2 different categories, qualifiers and weather phenomenon. First, the qualifiers of intensity, proximity, and the descriptor of the weather will be given. The intensity may be light, minus, moderate, blank, or heavy, plus. Proximity only depicts weather phenomena that are in the airport vicinity. The notation VC indicates a specific weather phenomenon is in the vicinity of 5 to 10 miles from the airport. Descriptors are used to describe certain types of precipitation and obscurations. Weather phenomena may be reported as being precipitation, obscurations, and other phenomena such as squalls or funnel clouds. Descriptions of weather phenomena as they begin or end and hailstone size are also listed in the remarks section of the report. 8. Sky condition, BKN 008, OVC 012 CB, always reported in the sequence of amount, height, and type or indefinite ceiling height. The heights of the cloud bases are reported with a 3-digit number in hundreds of feet AGL. The types of clouds, specifically towering cumulus, TCU, or cumulonimbus, CB clouds, are reported with their height. Contractions are used to describe the amount of cloud coverage and obscuring phenomena. The amount of sky coverage is reported in eighths of the sky from horizon to horizon. 9. Temperature and dew point, 18/17. The air temperature and dew point are always given in degrees Celsius. Temperatures below 0 degrees Celsius are preceded by the letter M to indicate minus. 10. Altimeter setting, A2970. Reported as inches of mercury, Hg, in a 4-digit number group, it is always preceded by the letter A. Rising or falling pressure may also be denoted in the remarks section as PRESRR or PRESFR, respectively. 11. Remarks. The remarks section always begins with the letters RMK. Comments may or may not appear in this section of the METAR. The information contained in this section may include wind data, variable visibility, beginning and ending times of particular phenomenon, pressure information, and various other information deemed necessary. PIREPs provide valuable information regarding the conditions as they actually exist in the air, which cannot be gathered from any other source. Pilots can confirm the height of bases and tops of clouds, locations of wind shear and turbulence, and the location of in-flight icing. When unexpected weather conditions are encountered, pilots are encouraged to make a report to an FSS or ATC. When a pilot weather report is filed, the ATC facility or FSS will add it to the distribution system to brief other pilots and provide in-flight advisories. The image above shows the elements of a PIREP form. Item numbers 1 through 5 are required information when making a report, as well as at least one weather phenomenon encountered. Pilot reports are easily decoded, and most contractions used in the reports are self-explanatory. Areas of precipitation and thunderstorms are observed by radar on a routine basis. Radar weather reports, RAREPs, or storm detections, SDs, are issued by radar stations at 35 minutes past the hour, with special reports issued as needed. RAREPs provide information on the type, intensity, and location of the echo top of the precipitation, Figure 12-11. These reports may also include direction and speed of the area of precipitation, as well as the height and base of the precipitation in hundreds of feet MSL. Cloud bases and tops, ceilings, and visibility are not detected by radar. The above radar report gives the following information. The report is automated from Oklahoma City and was made at 1935 UTC. The echo pattern for this radar report indicates a line of echoes covering most of the area. Thunderstorms and very heavy rain showers are indicated. The next set of numbers indicates the azimuth that defines the echo, 86 degrees at 40 nautical miles and 199 degrees at 115 nautical miles. The dimension of this echo is given as 20 nautical miles wide, 10 nautical miles on either side of the line defined by the azimuth and range. The cells within the line are moving from 240 degrees at 25 knots. The maximum top of the precipitation, as determined by radar and satellite, is 57,000 feet, and it is located on the 159-degree radial, 65 nautical miles out. The last line indicates the intensity of the precipitation. For example, in grid QM, the intensity is 3, or heavy precipitation. 1 is light and 6 is extreme. Please help us spread the word about Pilot Training System, and we look forward to further servicing your flight training needs.